A blank is a transformation in which the original figure and its image are similar. So we talked about transformations. You've got reflections, you've got rotations, you have translations where they slide, but all of those remain the same size. Dilation means bigger or smaller. That's what makes it similar. All of those others are congruent. So if you have a reflection, they're congruent to each other. If you have a rotation, they're still congruent to each other. If it slides, they're still congruent to each other. Okay, so a dilation is a transformation in which the original figure and its image are similar. If PQR is similar to XYZ, PQR is similar to XYZ, then PQ over XY is equal to blank over YZ and blank over blank. Okay, so what you want to do here is say, okay, PQ and XY are the first two in a line. YZ are the second two, so this has to be QR. This similarity statement says that P and X match up, Q and Y match up, R and Z match up. So it has to be that way. Now we're doing always this triangle first, so when we do the last one we have to say the first and last together. And when you have a triangle, you've got P, Q, R, so you have PQ, QR, the last one is going to be RP. So we have RP is proportional to XZ. Number 3 on page 418 in the chapter review. Describe the relationship between a ratio and a proportion. Give an example of each. Okay? The difference, the relationship between a proportion and a ratio. In a ratio, we're telling how two numbers are related to each other, such as 2 to 3. 2 boys to 3 girls in a room. If you have 5 students in there, you have 4 to 6. You have a ratio of 4 to 6. When you do a proportion, you're going to relate two parts. Okay, so you would say 2 is to 3 as 4 is to 6. So in a proportion, we actually have a relationship between two things, and we have the same relationship between another two things. So if we say there are 2 boys to 3 girls, but there are actually 10 students, then you have to figure out how many of those would be girls and boys and still keep the same ratio. So if it's 2 boys to 3 girls, 4 boys to 6 girls would be a similar ratio. So when you do a proportion, you're actually showing 2 relationships. The book answer is, in a ratio, 2 numbers are compared. In a proportion, 2 ratios are set equal to one another. The length of a rectangle is 20 meters and the width is 15. Find the ratio of width to length. Okay, it says the width is 15. It says the length is 20, but then it asks for width to length, not length to width. So when you do width to length, you have to do the width on top. So 15 to 20, and then you need to reduce that to 3/4. The measures of the angles in triangle U, this is number 5. The measures in the angles in triangle UVW are in the extended ratio of 1, 1, 2. Okay. So we have UVW. It doesn't really matter what it looks like. 1, 1, 2. Okay, that means this one is twice as large as either of these. Now if you remember, what we did is we assigned X to be the variable, and we know that in a triangle we have 180 degrees. So if we have 1, 1, 2 is the ratio, that's like this is X, and this is X, and this is 2X. So we have X plus 2X equals 180 degrees. X plus 2X is 4X equals 180 degrees. Divide both sides by 4, and we get X is equal to 445. That means these are 45-degree angles, and this is a 90-degree angle. But we have to always go back and ask ourselves, what are we asked for? It says find the measures of the angles. So the measures of the angles are 45 degrees, and 90 degrees. Find the geometric mean of 8 and 12. And you can actually write this out as a proportion if you want to. X down here, X up here, and 8. 8 and 12? 8 and 12. Okay, so we get x squared is equal to 8 times 12, which is 96. Okay, and then we need to be looking for perfect squares that can come out of that. Now, one of the things you can keep in mind is that you already have 8 and 12 kind of factored out because you multiplied 8 and 12 to get that, right? All right, so we have 4 and 3 here, and we have a 2 and a 4 here. All right, so look at this. We have 2 4s within these numbers. So we're going to take the square root of both sides. We get x equals the square root of 96. And so we know that 4 can come out as 4 times 4. So we have 4 times 4 times 2 times 3. And when we pull the 4s, the pair of 4s out, it becomes 1 4 on the outside of the radical. Because 4 times 4 is 16. What's the square root of 16? 4. And then on the inside, we still have 2 times 3. Since it's not a pair, we can't take it out, so we get square root of 6. 4 times the square root of 6.